Okay, so the jokes are going to be good for you guys. All right, here's the outline of what we're going to cover today. I'm going to start by giving you a motivation for why this presentation exists in the first place and why so many of you come back time after time. Then I'm going to get into real-world troubleshooting cases, and I've broken those down into various symptoms. I think that's a good way to look at it, to show you how symptoms can lead to solutions using various tools and techniques. And today's talk, I've got case examples of sluggish performance, error messages, buggy behavior, which is, it sounds like a Jeopardy thing, doesn't it? And then blue screens. I'll take blue screens for 500. So let's talk, this is the 2014 edition of Casey Unexplained. I've been doing this talk since like Tech Ed in 2007. But the fun thing about this talk is that every time I deliver it, I get to deliver a brand new talk with all new cases, new techniques. Of course, many of the same tools, but it's fresh every time. So if you've seen it before, these are new examples for you. And if you have not seen them before, or you haven't been to every single one I've delivered, you can go to the Mark's webcasts on Sysinternals, and I've got links to each previous delivery, at least the major releases of them at various tech eds. So if you like this content, I recommend you go back and look at the other ones, because every single case gives you a unique way of looking at a problem. And some of the cases I use different tools than I'll be showing you today. So go back and take a look at those. These are all based on real case studies, meaning that I either solved these cases myself using the tools, or people like you have solved them using the tools. And I think that's what makes them really fascinating. I love getting the cases from you guys where you start with some problem, some behavior, and I'm thinking, wow, how do you figure out what's causing that? And then you'll dive in through the tools in a path that I would have never imagined and make some leap that takes you to the solution just based on some clue you ran into. And I love actually going back and through all the cases and just looking at all the interesting ways people have solved them. Let me show you just how much material I've got. This is my... Oh, sorry. It'd help if I showed the PowerPoint. This is all you missed, by the way, because there's just that. So based on real case studies. So let me show you this is my labs folder where I collect all these things. And you can see all of the PowerPoints that I've got in here. I'm up to number 9, and I cut a new PowerPoint deck when PowerPoint starts to have Case of the Unexplained issues. And you can see it's somewhere around 10 megabytes of PowerPoint, then it starts to get unhappy. So I break them into that size. And by the way, just to give you an idea of how many log files and everything I've collected, if you take a look at the properties on this thing, about a month ago I hit 5 gigabytes, and so that's why I had OneDrive raise the free limit to 7. So the reason that we've got this talk in the first place is that many applications don't do a good job of telling you what went wrong when something goes wrong. And there's a very good reason for that. It's crappy program. No, it's not. It's that programmers write their code for ideal situation, for the configuration, the system configuration and settings and files as they expect them to be, as defined by a standard installation. What happens when the programs get out into the real world is that they run into reality. The reality of systems that have lots of different software installed on them, that have configurations that they'd never seen, that the developer never saw before, never intended, never wrote the program for. Systems administrators that go and mess with things, end users that go and mess with things and screw up with the configuration of the system. And then what happens is the code falls into some path that the developer never tested and never intended it to fall into. A common case is I go to open a file. That file is always accessible on any standard Windows installation. For some reason, somebody's locked down the permissions. Now it gets an access denied on the file open. The developer doesn't even check the error result to see if the file open failed, and then proceeds as if it succeeded, does a read file, doesn't check that, and then ends up looking at garbage inside of buffers that were never populated with data that were supposed to be there. Then they process that data, trip over some buffer overflow or some a pointer exception, and either crash or actually catch an exception and throw you an error dialog box that has nothing to do with the original root cause. So the purpose of this is to show you how to look underneath the hood of the application in Windows itself to understand where did things go wrong. What's the trigger that led to the problem? Not the symptom, but the actual root cause. And then be able to, using that information, mitigate the problem or fix it. And I want to make that clear that not every case is going to be one that you can solve yourself, because software, if it has bugs in it, only the developer can fix the bugs. You can identify the bugs, you can tell them about the bugs, sometimes you can mitigate the bug, but you can't fix the bug. And so even just knowing what's going on, what's behind some problem, gives you the tools potentially to mitigate it rather than fix it, and that's, I consider, a success as well. Here are the tools that we're going to use. These are all obviously the Sysinternals tools, the bulk of them that we're going to use because I happen to like those tools a lot. This is the site you can get them at, Sysinternals.com. And these are the list of the tools that I've used in various Case of the Unexplained talks. There's a total of about 70 tools that I've got active right now on the site. And sometimes I age tools out when they no longer become useful or replaced by an inbox tool. But you can see just a subset of them really are the ones that show up in a lot of these troubleshooting cases. Of course, the big three, Process Monitor, Process Explorer, and Autoruns, are ones that we're going to definitely cover. Also, another tool that I use is it's called the Debugging Tools for Windows. WinBag, as it's affectionately known, and you can go download it as part of the SDK or WDK install. You can see a link right there that will tell you how to get it. That's a free tool to download and install as well. The official book on Sysinternals tools, I recommend that you take a look at it if you want to get deeper into troubleshooting, is the Windows Sysinternals Administrator's Reference. How many people went to Aaron's Sysinternals Primer talk this week? So he does a great job on the tools. He also did a good job writing a lot of the book. So good that I gave him his name on the cover after he whined a lot. I said, okay, fine. And there it is. And I think he makes fun of me for even allowing him to do that. And I'm also really annoyed at the foreign translations that don't honor this. But so there's full chapters on those big tools, and then it covers all of the tools on the site. Let's get started now with the first case. It's a sluggish performance case. By the way, how many people have experienced sluggish performance on Windows? Oh, just kidding. All right, this case started when a guy that happened to be a systems administrator on one of his systems noticed that the system would sporadically behave sluggishly. And the first thing that many systems administrators do is go to the event log to look to see if there's anything that might indicate a cause. And in this case, you can see in the event log, he came across this, application error. And when he expanded that, he saw that the defaulting application path, which was search protocol host. This is a built-in piece of Windows. This is that little executable that every time you touch a file on disk, it wakes up and gets all excited that it's got something to do. And then after it does that, it goes away. It's like gets bored and leaves. You touch another file, it wakes up and comes back and gets active again. Its job in life is to sit there and scavenge your disk. So he saw this. The question is, why is this thing crashing? Maybe there's something, maybe it's not an inherent Windows bug, but caused by some other piece of software that is impacting the behavior of that executable. He needed to look inside the process to see what was going on, and for that he turned to Process Explorer. How many people have run Process Explorer? How many people have never run Process Explorer? That's good, you're learning. Because I know some of you haven't, but you know now not to raise your hand because then I'll make fun of you. Now, Process Explorer, let's take a quick look at Process Explorer and the various things we see for those of you that maybe haven't delved into the details of what you're looking at here. But first, obviously, you get a process tree here, which shows you parent-child relationships. The part of the tree that I focus on to highlight that, is Explorer right here, which is the shell. When you log into Windows, this Explorer process is created because of a registry key that specifies this is the default system shell. And then whenever you launch things as you use Windows, they are born from Explorer. If you see a process that is left justified, that means its parent has died. It's a little orphan process, and you feel sorry for it and donate money to some charity so that it can have a nice, nurturing home at some point. But for each process, in addition to seeing its parent-child relationship, you also see information about the process executable, starting with the image name, of course, which is just the name on disk. That's the first column. Then you see process ID. You see things like the private memory usage. That is the memory that is dedicated, the virtual memory dedicated to that process and no others, as opposed to virtual memory that's shared by different processes, like the file system cache. The working set that's dedicated to that particular process, that meaning that's the physical RAM that's assigned to this process, and that actually can be shared, some parts of that, like the file system cache. The description, and this comes from the version information, so developers have to put this information in their image and embed it, and they can put whatever they want to in there, and Process Explorer simply reads it out and shows you what they said the description and the company name is. Some software, unfortunately, omits one or other or both. Like if you saw the malware talk, you know that malware oftentimes omits this completely, which is an indicator of potential malicious malware. Almost all legitimate software these days includes both of those strings in their version resource. Now let's take a look a little bit deeper into processes. First thing is you can add a ton of different columns to the display to show information that you might be interested in about the processes. This is just one page of many pages, as you can see, to affect the process view. This is like, hey, if you want to see the command line, if you want to see which user is running it, if you want to see what terminal server session, Windows session the process is running in, if you want to see the package name, if it's a modern Metro Windows 8 App Store app that might even be universal, you can see the integrity level, other security information here. And then there's tabs also for adding columns related to process performance, like the CPU history, the start time of the process, a process timeline that shows you its activity timeline relative to the other processes, I/O counters, so if you want to see how much I/O it's doing, even I/O per refresh of Process Explorer. You can see GPU usage of the process. You can see process memory usage divided into virtual memory and physical memory, as well as graphical object memory, as well as kernel memory. So a whole ton of different things we don't have time to delve into that you can see in the process view. To take a look at those things for a particular process, you can open the image dialog. And this will show you information about the process, like the same things that you saw, the description and company name, the version, when it was compiled, so you can see how old this thing is, and this is relatively fresh. Explorer.exe was updated on March 3rd. You can see the path to it. You can open to see where it is, and it'll take you to Explorer.exe right there, so you can go jump and take a look at the image there. The current directory, the auto start location. Remember I mentioned that Explorer is the shell, and this is how Process Explorer shows you that Explorer might have been auto started using that location right there. The shell auto start location points at Explorer.exe, and if you hit Explorer there, it will take you to the shell. Well, at least it should have. For some reason, it's not taking you there. Let's pretend we didn't see that. Let's try that again, actually. There. Now that's taking you there. So there it takes you to the shell. You can see Explorer.exe right there. And then down here you can see the parent process. So this is userinit, which is the parent of Process Explorer. A lot of people don't know it, that Explorer was abandoned by this process userinit, who unfortunately got old, young age, actually unhealthy living, doing a lot of things like doing group policy updates, which is really unhealthy living, and at least in Microsoft's corporate network, and then ends up launching Explorer and then dying. And so Process Explorer, because I've launched it as to run it logon using an auto start method there by putting it in the run key, it is there to see the end of userinit, and so that's why it knows that that was Explorer's parent. If I just exited Process Explorer and launched it now, you would see that it would only know the parent process ID, not Explorer's parent's process name, which it can only know if it's alive, if it's around at the time Process Explorer is running. Some of the things you should do besides make it auto start like that when you log into Windows is to set some of the options here, like hide when minimized, allow only one instance, and the other one is this one, replacing Task Manager. If you do this, it takes over Task Manager. So what's your favorite way of running Task Manager? Anybody? Because there's a bunch of different ways. Control-Shift-Escape, that's one of my favorite ways too. And there's Control-Shift-Escape. Voila, we have Windows the way it should be. By the way, people ask me, why isn't Process Explorer just in the box? Because that would slow me down. because, well, Windows ships how often? Well, it's like every 6 months now. But that would mean that I wouldn't be able to update Process Explorer whenever I wanted to, and you wouldn't know how to go get the latest version. So keeping it on Sysinternals is what makes it something that I can refresh at my own rate. There's some new features. I mentioned run it logon. There's WMI provider hosts. So one of the things Process Explorer can do is look inside of hosting processes. Service hosts are one type of hosting process. You can see here that when I hover the tooltip over this service host, it will show me the services running inside of it. These are the background jobs, basically, the daemons in Windows. And other hosting processes like RunDLL32, DCOM, host, and now WMI provider, it will show you what's running inside of those. So this now will show you which WMI provider service hosting process is what that they are hosting. In this case, this is hosting the Intel WLAN event provider. So if that process was going crazy, now you could go look, very easily see it's probably related to this third-party DLL loaded inside of this. Also, DPI awareness. This is an option that I added at the request of the Windows graphics team, as their Windows 8.1 has this new DPI awareness setting that you can turn on and off, and applications can register with the system saying they're DPI aware. There's a new API you can call to get that, and Process Explorer shows that. So useful for developers writing apps that want to work nicely on different size tablets, for example. The big new feature is VirusTotal. How many people were not in the malware session earlier? So a few of you. So those of you that didn't see this, now Process Explorer has the ability to go out and submit hashes to an online virus scanning service called VirusTotal. And I've already configured Process Explorer here in the options to go and check VirusTotal, submitting hashes of the files to see if VirusTotal knows about the files. And what you can do is submit unknown executables. That's not checked by default in case you don't want your binaries in your own line of business applications going up to a third-party service. You can check that if you want it to automatically submit, which you might want to do for malware checking. And then it shows you the positive detection rate of the antivirus engine. So, for example, this was scanned by 53 engines. None of them flagged it as potentially malicious. And I think I don't have anything that's flagged right now on my system. Occasionally, false positives will show up, even for legitimate software. And then, in that case, you'll see red show up here. You can simply click on this, and it will take you to the appropriate site, web page, and show you the scans. So this was last scanned on May 14th, so just a few days ago, and all the engines came up saying it was clean. So that's the big one, and obviously very useful for scanning malware. Let's get back to this particular case. What they did when they ran Process Explorer to take a look at what was going on with Search Protocol Host is they saw a lot of green like this and red. And that brings me to the highlight colors. If you look, there's a bunch of different colors visible here. There's cyan, which are these modern Metro apps. There's blue, which are processes running as you. I would say the boy process joke, but I think people don't think that's funny anymore. And then there's pink. Do you think it's funny? Pink, the girl processes? Yeah? Okay. Pink are the girl processes. Okay, never mind. And then there's white. And white's all the other processes that don't have a color coding to them. You can see the full set of color coding here in the Configure Colors dialog. So there's the own processes, the service processes, suspended processes are gray, packed processes, some that aren't enabled by default, and here's the immersive, what's officially called immersive processes. You can also change graph backgrounds, by the way. I'll get that in a second. But here you see new and deleted objects. And what that's used for is if you've got a process that's new, it shows up in green. You can configure how long it'll show up in green. I've configured it for the max of 9 seconds. And then if you delete it or terminate it, it shows up in red to tell you this thing is gone. So it's very easy to see processes coming and going. And that's exactly what he saw, is a whole bunch of green and red as Search Protocol Host kept firing up and dying. And this corresponded, this is obviously the reason the system is sluggish, is these launching multiple times a second, apparently crashing, and then restarting to go do its job. So he wanted to look and see why is this thing crashing? Now, it's not easy to take a kernel debugger, which is one of the ways you can figure out why something's crashing, and dynamically attach it to the process so that when it crashes, the debugger breaks, and then you can look at what's going on inside the debugger. In this case, the processes were so short-lived that he couldn't do an attach to the process before it crashed. So he turned to a tool called procdump. How many people have used procdump before, just out of curiosity? So is Andrew Richards in the room here, by the way? Andrew? No? All right, I can talk smack about him? No, he's probably hiding in here, so I better be careful. Andrew did a lot of contributions to procdump. He was in Microsoft escalation engineer, and he wrote, for the purposes of Microsoft support, a bunch of enhancements to this tool with me. And one of the cool things about this tool is that you can configure it to catch a process dump of any process that crashes on your system very easily. And you can do it very dynamically as well, so you can turn this feature on and off. I've got a process that I'm going to show you. It's called Acvio. Has anybody heard of Acvio? It's actually an unsigned tool here. And it was written by my co-author on Windows Internals, Dave Solomon. If you know Dave, the last time he programmed was for VAX VMS. And so when it came to Windows, he tried to write a program to do something. All he could do was get it to crash, and thus it became the example of the crashing program in our talks. And so he named it Acvio. And so when you run Acvio, it just crashed. You saw the cursor flash? You saw that was a crash. Crash. So how can we capture a dump of that crash? We can use procdump. And you'd use the -MA to capture a full process dump, -I. That configures procdump as the last chance debugger on the system. And what it does when it catches a last chance crash of a process is create a crash dump file of the process in the directory you specify. And what I do on all my systems is do this, and I point at dumps. And so now, if I do Acvio, you see a flash of a console. That is procdump. And if I go into dumps, it's interesting when you do this, there's all sorts of crashes that happen that you probably never aware of, because processes like Acvio that are headless and background system processes, when they crash, there's nothing emitted. And so all of these are ones that I just this morning was like, oh, I wonder if I've got anything in my dumps folder, and I've got a whole bunch of things that have been crashing that I had no idea. Now, these are obviously not good things. We should spend a few seconds and take a look at why all of these have crashed. So that's what we're going to do for the rest of the 75 minutes. I'm just kidding. What we're going to do is go back to this case where this person knew about this facility and configured procdump to capture dumps on his system so that he could catch that search protocol host dump. And then the next thing he did was open up the debugging tools for Windows, WinBag it's called. Now, there's a few things that you need to do when you set up WinBag. One, ideally, is configure the symbol server. And what this does is it's a string that you don't need to memorize the reasons for these parts except for one thing, and that is this part right here is where you want your symbols that are pulled down from a Microsoft symbol server for any images that Microsoft creates that we index on the public symbol server down into this folder. And what that does is makes it easier to look at dumps, because any Microsoft images in that dump, you'll see function names instead of just offsets into DLLs. So it's great for hints about what's going on inside of a process. Once you've done that, you're ready to go on taking a look at a crash dump like the service host crash dumps, which this person sent me as part of submitting this case to me. So if I go into case of, and I go to sluggish, where is it? Sluggish, random sluggishness. And he sent me a bunch that it captured. Let me make the font a little bit bigger here so that you can see what's going on. And you know what? Oh, no font of that name. And then there's a few things you can do. One of the things that I recommend you do is just do analyze-v, because that tells the debugger, hey, why don't you go try to figure out what you think caused the crash? There's a built-in heuristic engine inside the debugger that will look at the stack, that will look at the pointers and the registers, and then will come up with its best guess as to why this thing is faulted. And this will just take a second. This is timing out because this is an internal configuration, so it goes to Microsoft internal site for some additional configuration. But it dumps the stack trace. Let's just spend a second here on stack traces. This shows you the reverse execution to the point in time that we're looking at inside that process. Not just that process, but a particular thread in that process, because processes have typically more than one thread that executes code. And this thread began its life here in RTL user startup, then it called into this function, then it called into search protocol host C filter thread, eventually it called into mappy h some DLL. That called into IMAP session, so it looks like it's indexing email, on my guess, and then called into this DLL, and this DLL ended up jumping to nothing, 0, and that's why it crashed. If you scroll further down, here, analyze-v is saying, yeah, I think this guy is responsible, that DLL we were just looking at. You simply click on this hyperlink, and it shows you what information was captured in the dump about the image. And this might not be in the crash dump. If not, then you need to go look at the file on disk. But in this case, it has the image header information and the version information from the image in the memory dump, in the process memory still. And we see the file description, Enterprise Vault Virtual Vault. So at this point, it looks like this third-party DLL is causing the problem in this system. How many times have you come across something on your system and you're like, what the hell is this doing on my system? Because that's what happened here. He said, I have no idea what this Enterprise Virtual Vault is doing on my system. It probably came with some crapware with something else. Or MSI, or the IT department installed it and it's causing me problems, and maybe they'll get around to getting a new one. So, uninstalled it, and that problem went away. So uninstalling it, rebooting the machine, search protocol host was then happy, and he fixed the problem with this random sluggishness that was going on in the system. So to recap, he used Process Explorer to get an idea of what was going on here with, well, first the event log, then Process Explorer. In fact, Process Explorer, if he'd gone to that first, he would have probably had the clue just from all the red and green flashing of search protocol host. Proc dump to capture a dump, and then just basically loading it, saying, you figure it out, and then clicking on that, and he was taken to the root cause and solved the problem. That's how easy it always is. It's amazing. All right, this next case. This guy went and bought a new laptop. Very nice laptop, and this guy likes to watch Blu-ray movies on this laptop. So he bought a laptop, high-res screen, nice like 15-inch monster laptop display so he could go on trips and spend a lot of time on the road, and he watched his nice Blu-ray DVDs while he also does work. So he sticks in the DVD, first DVD, he's watching it, and all of a sudden it's just like a minute or two into it, it's like, starts glitching. It's like, what the hell? Then the glitching stops, and a minute or two later, it starts up again. So he's like, oh, great, I've got a broken DVD player. So what am I going to do? So first, maybe it's not the DVD player itself. Maybe it's the software. So he goes and gets a brand new, so it's like, you know, some third-party DVD player software, and it's the free version that came with the PC, and he's like, oh, maybe I need to shell out some money to get the real thing. Maybe that doesn't glitch. Maybe that's their trick to get me to buy the real thing. So he goes and buys the real thing, and the thing still keeps glitching. So now he's like, okay, maybe it's a bad device. Maybe other people have experienced this. So he goes into Device Manager and sees that it's this HP Blu-ray disc player, and he searches online to see if anybody's talking about this thing. And he finds some people having some kind of random complaints that may be associated with this thing, but nothing that points at the exact same problem. Nothing that's like, oh, my DVD playback glitches every few minutes. He also goes to HP site, no firmware update available, so what does he do now? He turns to Process Monitor. Process Monitor, if you went and looked at my labs directory, you would see almost all the cases in there are Process Monitor cases. 80-some% of the cases I get and I solve myself are solved with Process Monitor. From malware to sluggish performance to error messages, every single kind of symptom, Process Monitor is most likely to be the tool that points you at the root cause. It's been so versatile at finding and pointing people at root causes that Dave Solomon, again my co-author on the book, came up with the slogan a while ago, when in doubt, run Process Monitor. And what I try to do is get everybody to take that home with them and to spread the word. And so let's practice. When I say 3, let's all say that together. Okay? 1, 2, 3. When in doubt, run process monitor. Wow, that's pretty good for the first time. We're going to practice, though, so get ready to do it again in a little bit. Actually, if you're on Twitter, it'd be, I've always wanted to have a trending topic on Twitter. If you could all tweet right now, hashtag #procmon when in doubt. Yeah? No? I don't see anybody interested in this. All right, never mind. What's that? Oh, the internet sucks here. Okay, well, that's a... And by the way, if you'd like to submit to Twitter that hashtag, something with that hashtag repeatedly so that we do get it trending, just let me know and I can give you a little piece of software you can run on your machine. So this is what Process Monitor looks like. You just fire it up and it starts collecting traces of a whole bunch of different categories of information. Files, registry, network, also process and DLL startup, thread startup, and termination. You can see that even in an otherwise idle system that I've already got 380,000 events that have been collected, Process Monitor is able to handle literally tens of millions of events. So it's pretty robust in handling this kind of activity. For each event, it will show you the process performing the event. By default, it also shows you a time of day column, which I've removed just to save screen real estate. Shows you the process ID, shows you the type of operation, and the icon represents the category, which maps up to here, which are what I call quick filters. I'll explain that in a second. The operation name, the path of the operation, so if it's a registry operation, obviously you're going to see a registry path, the result, and then for each operation, you'll see details about that operation. So this is a registry read, it looks like, or a registry query value. And you can see that it's a type D word, length 4, and the value being read is 13. So this is the kind of detail you get, so you can see exactly what registry values have been read or written by a process. So a lot of people don't realize that it captures TCP/IP activity. So we can remove these, unselect those buttons, and that acts as a filter to say, I don't want to see those things if you deselect them. And now we've left processes, and so process and thread activity as well as network activity, and now we can see my system going out on the network. So it's kind of a lightweight netmon type of tool as well. It doesn't show you the actual packets, but it'll show you what your system is talking to. Let me talk just about a few more things before we get back to the case. That was one way to do filtering. I'm going to do Control-R, and that unsets the filter to the default filtering mode. But the key to using Process Monitor is filtering. You've got to get really good at narrowing down the hundreds of thousands of events to just the ones that are going to give you some clue as to what's going on. And there's a few different ways you can filter, depending on what kind of clues you think you might need to go after. One is, let's say it's a particular path that you're having a problem with. You can right-click on any value in any of these columns, and you get what I call quick filters. So this section right here, you can see, gets populated whatever the value is in that column, and you can, I accidentally pressed include, and you can press include, exclude, highlight, and if you do highlight, I just highlighted everything, or copy, and that will copy it to the clipboard. A relatively new feature, let me do Control-R, is edit. So let's say that I want to capture everything that's going on under this registry key, but I want to up down to here, down to MUI. And what I would have to do is add that as an include filter and then go to the filter editor, which I'm going to show you a second, and then fix that up. But I can do this a little more simply by saying edit filter, and this populates the filter dialog with path is, and then that, and then I can simply chop off the last part, say add, and now, okay. And now I've just set a filter. I think I chopped off too much. Let me, or not enough. I can just click that back in there. I think the problem is, oh, you know what? I need to say begins with. So these are the expressions, is not, less than, more than, because it understands numeric fields as well. And I can say begin with, and then say apply. It'll remind me I didn't add it to the filter, and then now I'm seeing everything under that particular key. So those are a few ways to filter. Another way to filter is, let's say that I want to see activity from a particular process that I've got running. I can, for example, launch Notepad, and if I want to see exactly what Notepad did, I take the bullseye, I drop it on Notepad, and I've just filtered for Notepad by itself. So that's yet another way. And then the final way I want to show you before we move on is Control-T to open the process tree. Looks a lot like Process Explorer's process tree with the parent-child relationship. This will show us all the processes that existed since I started tracing, even the ones that have exited. And those ones that have exited show up as dark gray. So here's a DLL host that exited sometime while I was talking. And then you can simply go and say, select this and say, go to event, include process, or include subtree. So I could look at all of the things IE has done since we started talking. And it hasn't done anything that I can see. So there's IE's doing something. Maybe I cleared the history. So that's yet another way to capture, to do filtering. Let's get back to this particular case now. And I've got that log file that he sent me. So I'm going to go and open it up. And that is this one right here. And so he captured a trace until the Blu-ray playback. You can see his Power DVD playing the Blu-ray until it started to stutter. And you can see the Blu-ray player's drive G. There's the Blu-ray files. And he scrolls through through the trace after he got the stutter captured. And then he notices this. This trace starts to look different. And by the way, he set a filter just for G because he knew that's the DVD player's disk drive. So he set a filter for G. And he sees all of a sudden WMI PRVSE show up. What is that? That's the WMI provider host. This is the WMI service that you can perform Windows management instrumentation calls on the system, even remotely, or from another process on the system, doing things like this is SimMom and all that stuff that Jeffrey Snover really loves to look at what's going on in a system. So something is causing WMI. Something's making WMI calls that are starting to enumerate all of the contents of the directories under the G. And this corresponded exactly with the stutter. So the question is, what is making these WMI calls? What he did at that point was, being a systems administrator, he knew that you could turn on WMI tracing. And WMI tracing, event log tracing, for all of the activity that WMI is providing on behalf, executing on behalf of another process, you can turn on by going to Event Viewer, going to View, show Analytic and Debug Logs here, selecting that, and then once that's enabled, you see this show up here, Trace. And then you can right-click and say Enable. And what that will do is turn on WMI tracing for activity. And this is extremely useful because otherwise it's almost impossible to figure out what is causing WMI provider service processes to act up. So he turned that on, and what he got in the WMI trace event log at this point, he started scrolling through the events, and he came across this one that references somebody executing this command, select star from Win32 CD-ROM. So something here is actually enumerating all of the files underneath the G drive as suspected using WMI calls. Which process is doing it? Helpfully, WMI tracing shows you the client process ID. So what he did at that point was go back to Process Explorer, and here's process 1940, and it's this thing, a Bluetooth application, because obviously Bluetooth needs to read your DVD drive. So he's like, what the hell is that? So at that point, he stopped the service just to confirm it was really that thing's fault. The stutter went away. Now, the next step is like, okay, maybe he wants to use Bluetooth at some point, pair his phone or whatever. So he went to the website of the vendor, Raylink, which he saw from Process Explorer, checked, and sure enough, there was a new version. Here's him installing it, and here's the updated version. After he installed that, he captured traces and saw that this new version didn't do WMI calls anymore. So why it did them in the first place, nobody knows, but using Process Monitor, Process Explorer, the event log, he was able to get down to the fact that there's a new version that could fix his DVD playback problem. This next case I got literally this past weekend, somebody sent me. So this is fresh, hot off the press. This company it's a church, and they've got the system of checking in kids that come for daycare or lessons or whatever, and they print badges for them. So they keep track of the kids and make sure that the kids are accounted for all the time. So they've got printers that print these badges as the kids are checking in. They've got a whole bunch of printers. They've got 8 new printers that they freshly deployed a week and a half ago. And what they found is at these various stations that are configured to talk to this pool of printers, that some of the printing would slow, like it'd take 10 or 20 seconds to print the badge. And other ones, like you press print in the app and it would print the badge right away. It's like, what the hell, why are some taking 10, 20 seconds? That's really annoying as a whole bunch of kids are coming in. So they take a look and they kind of narrow it down through experimentation, and they find that 2 of the printers print fast and the other 6 are slow. They're all the same printer manufacturer. The configuration on all the end user systems are the same. In fact, you can do this test from different workstations and the behavior is the same. It's the printer that is the difference in behavior. So he captured a process monitor trace. And this is an example of kind of how people figure things out in ways that I'm impressed with, because here's the fast printer case. And I'm not even going to bother opening the slow one. Well, I might as well. And the slow one, and this is the ideal situation when you can go and compare traces side by side. This side-by-side comparison that he performed is one of the more complex ones that I've seen. Because normally when you compare traces side by side, and we'll see some later, you can see the flows kind of nice, matching up. And then all of a sudden, one trace will start to have a different shape. And that'll tell you approximately where things are diverging. In this case, the traces look very different, and I spent some time looking through this going, how the hell did he figure this out? I'm going to jump right to where he spotted a difference in the traces, and it's right here. It's this reg query key, and the reg query key of this path right here. So it's Windows NT conversion, print providers, client-side rendering, print providers, servers, print, monitors, client-side port, and if you look, the value here is this right here. This funky configured key. Users S1-50-20, which is the network service, printers, whack, caret, print, so some regular expression type thing, lex-sp, that's the name of the printer. He went back and looked for that same thing on the slow printer trace, couldn't find it. So at that point he's like, I wonder if that's it. And so what he did was he took a look at that registry keys settings. He created this reg file, and he went and from the export of that key, took it over to the others, modified it in this way here in the registry editor. He found that he could put this GUID here. He didn't have to actually put a GUID, but he put references to this GUID in another place in another reg file, which is right here. You can see he made these things, point at that. So these don't have to be real GUIDs. They're just a connection between this registry key under printers and those other under print monitors. Made those for all 6 printers, or all 8 printers rather. Imported in the registry. Printed, whammo, fast printing. So this is one of those ones that's like, oh, bravo, well done. I'm impressed. I don't know if I actually would have figured that one out. But it shows that with some persistence, in this case, looking through log files, and probably took him 15 to 30 minutes to go through there and identify that's the thing that's actually throwing things off, and led him to the solution, which is one of those mysteries. I mean, he said, Mark, you know obviously why that registry key makes things print fast, don't you? And I said, well, I haven't answered him yet. So let's talk about the next case, error messages. So in this case, somebody had upgraded to Windows 8.1, and they started to get these messages every time they logged on the machine. And every time, there's a friend of mine, Sergio Calderon, that lives in South America, and he sends me lots of cases, and so I get to practice my Spanish every time I come across these. So, problema al enseñar, C:/, P, R. Oh, no, I'm just kidding. And it says it can't find the path specified. So what is this? Obviously, what you're going to turn to is autoruns to figure out why Windows is trying to access these invalid paths. How many people use msconfig? Oh, I thought you learned. I guess it was just luck last time. But msconfig, for those of you that missed the last session, it was reimagined in Windows 8 along with the rest of the things in Windows 8. And you can see that it's a big improvement over what was there before. But actually, you shouldn't even go to the Startup Manager, which has been moved to Task Manager, and there has been some improvements there, but it still only shows you a tiny subset of what's going on in your machine. You should use autoruns, and I'll just quickly run autoruns. It shows you things that are configured to auto-start on your machine when you log in, when you boot, when you run, when you print, when you play a audio clip, when you play a movie, when you anything you can think of that might activate. And now where it takes advantage of all these things, I've left it with, I've turned on filters to show you only unsigned code that is not Microsoft, and that's because Microsoft code never has any problems, so you might as well just filter that stuff right out. But it actually, in most cases, it is some third-party thing, and so then this lets you focus just on the things that are not inherently part of Windows or Microsoft code. And you can see that there's different color highlights here. Blue lines are entries, so places where stuff gets configured. So here is the task scheduler, and there's a few things. Oops, I didn't mean to show that. And there's a few things that are configured there. And then you can see like drop handlers. So I've got 7-zip. Color coding, the blue is the section titles. The pink means that it's unsigned. So that's all that means. And then there's finally yellow, which means the file is not present on the system. So there's dangling auto-start entries, which are almost always innocuous, no big deal. But in this particular case, let's go take a look at this auto start Windows 8.1 upgrade, run DLL errors. And when we load that in, we will see that there are, sure enough, some yellows here in the run key. Where are they? Actually, which ones did he complain about here? SM update. I lost track of which one am I doing. Is this it? No, that's mine. Here, SM update. And here you can see these are the ones that something was pointing at sysmenu.dll, 2 auto-start entries here, and that is in the task scheduler section. So there were scheduled tasks configured to launch at logon these 2 activations of DLLs. That file was missing, so that's why you're getting the error messages from the task scheduler service popping up and saying, I can't find those things. So he did a search, and this link right here points you at this SM update, which says that this is potentially unwanted software, or PUS. So actually, I'm coming up with a new campaign, marketing campaign for autoruns. It's your dermatologist, and it squeezes that pus right out of your machine. So, you like it? It's kind of gross, isn't it? But all right, so maybe I won't go with that. I'll think of it. I'll go back to the drawing board. Anyway, so what he did was disable those entries, and the problem went away. And you can disable the entries by unselecting. Never delete. Golden rule number 1 in troubleshooting: do not do something that you can't undo, because you never know if you're going to make the problem worse, or you've just gone down the wrong path and you confidently blow away your machine. So make sure that you can undo it, and the way you do that in autoruns is just to uncheck, because you can always come back and recheck. You can even do it to an offline system. If you make your system unbootable by unchecking, boot into Windows to go, boot into safe mode if that's what's necessary, and then you can point at the offline system and recheck the items, and you'll be back in business. This next case is a case of a failed Windows 8.1 upgrade. This user was trying to upgrade from Windows 8.1 Media Center to Windows 8.1, And the installer kept restarting at the 50% mark. Let me see if I've been able to recreate this. Oops. Computer's low on memory. So let me see if I... No, didn't mean to do that. This was in the middle of... Oh, okay. The update failed here, and it didn't restart. But this is what he saw. Your Windows 8.1 install couldn't be completed. Something happened in the install of Windows 8.1 can't be completed. Helpful follow-up to that error message. Try again. Go ahead. So he tried again. Download goes to 50%. Boom. Resets. Gets this message again. So he's like, what the heck is going on? So he, being a systems administrator as well, goes to the Windows Update. He knows that when you're updating things, I meant to go to the desktop, that you can go to C:\Windows Update log, and he searched through this, and he searched for, what's the name? 4201C, 4201C, and he came across this. In fact, I recreated this problem on this machine, so there's a bunch of these because I let it try multiple times. And you can see here's more. And if we go back and take a closer look at that error message, it says post reboot, saved install for registered cookie, blah, blah, blah. Installer completed process return code, this, result that, exit code that, handler, end, Windows setup install. So this obviously had something to do with the error. He being a systems administrator as well as a part-time programmer knew about a tool called ERR. How many people know about ERR, error? So error is a cool tool that comes with Visual Studio, and if you type in an error code, it'll tell you what that is. In this case, NH result, severity failure 1, so this version of error doesn't know about this particular error code, which must be relatively new, but it is a Windows Update error code, but didn't really help him. So at this point, he turned to Process Monitor. So Process Monitor, let's go open the trace he collected of the point where the thing fell over. Here's what he was faced with. This massive log file of a whole bunch of activity. Some of it is from that setup host that is performing this installation. One of the things you can do to quickly try to zoom in on what is causing a problem is look for unusual error codes. And one of the error codes that most commonly is responsible for causing problems is access denied. So he went to Tools, Count Occurrences, Results, and this is a tool that will show you the total count of each type of result in the trace, result being an error code, and then count. So you can see in this trace there's 342 buffer overflows, which are innocuous error actually, but there's an access denied here, 4 of them. So what he was looking for is, hey, is there any unusual error codes here? Access denied, let's investigate those. You can set a filter for this by opening the filter dialog or simply double-clicking. So I've just set a filter for that error code, and we can see setup host is creating a file, and that file is in program data, Microsoft Crypto RSA machine keys with some GUID, and access denied. So he, just for the sake of trying it out, sets permissions on that to give admin full access, so he wasn't making permissions any weaker because admins are already admins, so he gave admins access. Up to that point, it only had system, and there was problem solved. He also found when he was searching online that other people had been experiencing this. Anybody with Media Server on Windows 8 ran into this problem, so he posted the solution, and a whole bunch of people said thank you and sent him free beer. People never send me free beer. Hint. So this next case is similar. This is a Windows installer failure, similar in the sense that Windows Update log or verbose logging led to the root cause. A Windows installer package failed to install on this one particular Server 2008 R2 system, but on other systems installed successfully. So what the user did was follow this KB article, to turn on MSI installer verbose logging and looked at the log file and saw this error code here around the time of the failure. Perform typelib failed with error code 11 and function code this. Very similar kind of code to the one we just saw, 8002801C. And he also turned to the error utility, and it said error accessing the OLE registry, which kind of makes sense if you're familiar with OLE and that old COM style of programming. Typelibs are the type libraries for OLE components. And so something was failing to register the type library. So he had to look a little bit deeper. Of course, the tool he turned to was when in doubt, run process monitor, yeah. So what he captured a side-by-side trace. Let's pull those up. And here we go, the installer failure, failing here on this side. Let me clean some of this other stuff out so we get cleaned up. And let's put working on this side. And this was a case where he was able to kind of look at the shapes of the curves of the traces, and you can see, is that the right one? Failing and working. And as we scroll down here, I'm going to go ahead and press F6. What I did was I set a bookmark. One of the things that you can do in process monitor traces is type Control B or right-click and say set bookmark, toggle bookmark, and that will set a bookmark in the trace that you can then quickly come back to just by pressing F6 to do basically a search for bookmarks. If you want to get rid of the bookmark, type Control B. You can do this on a trace that somebody sends you. You can do this on a trace and then send it to somebody and say, hey, it's problems around this case. So what I did to save a little bit of time here was set bookmarks in this trace to take us to where things are kind of lining up and where things went array, where he found a difference. So you can see here, and I don't know why the list view wants to jerk over like that. What you can see here is MSI exec is looking at this particular key. It's the same key on both sides. And then one side looks different than the other. You can see this guy goes into Win32, this guy goes into Win32, and then he goes into helpdir, and this guy doesn't. So the question is, why not? For that, he needed to look a little bit deeper too. What's causing MSI exec to behave differently on one system than the other? For that, he turned to the stack trace. So you can right-click and say stack, and this will show you the stack trace of a particular operation. He did this on a bunch of them and then came across the open of this registry key and compared them side by side. And let me pull into focus the exact where the difference is, and it is here. It's visible now. Has anybody noticed where the difference is? It's kind of hard to see, I guess, with the fonts screen being so far away, but it's right here. There's this DLL in this trace, acgeneral.dll, that's not in this trace. Between the reg open and the fast reg create, if you come over here, reg open, fast reg create, no AC general. So what is that thing? Double click. You see which, it's the Windows compatibility DLL. So something to do with AppCompat. Something on the failing side didn't have this AppCompat shim that is apparently necessary for the registration of this thing. Why is AppCompat not working? So just on a lark, he went back to the original, that failing trace, and he searched for AppCompat. AppCompat. And this is faulting in stuff from the disk. And he found some false positives, but then he came across, whoops, I think I just skipped over it. Ah, here it is. He came across this. MSI exec, something inside MSI exec, querying this registry key. Disable, AppCompat disable engine, and if you look at that key, that's a 1. If you look at the other side, it queries that key, AppCompat disable, and that's going to be a key that's not present on the other system. So question is, well, how did that get there? But nobody really cares about the answer to that. They just want to fix the problem. So he jumped to the registry. You can do that by doing a jump to. And this is just going to take, well, I'm not launched elevated, so it can't drive regedit. But what that would do is take me to that registry key. And then what he did was flip that 1 to a 0, tried it again, problem solved. So he pushed that key out to all the systems on the network, and now he got that problem fixed. So great example of a side-by-side comparison, looking at shapes, identifying one difference, and then following it up to find out the real root cause of the difference between the two traces, plus looking at the stack trace. Without the stack trace, he wouldn't have had that application compatibility hint. So it's a great example of how you can look inside of a thread, an operation stack, and figure out another clue to lead you to a solution. Okay, we got a buggy behavior next. Now what's buggy behavior? In this first case, the administrator, you know that with Windows 8 is this tie-in to Microsoft account, what's formerly called Live ID, and you can log into your systems using that. Well, in corporate networks, most people don't like to do that. They like to use corporate logins, not live account logins. And there's an option on the email client that you can tell it not to require an MSA. So you'll be able to use other credentials to log into the mail client. And the administrator used group policy to go push out this setting, allow Microsoft account to be optional for the mail client. You can see here's the templates, components, Windows app runtime. And that applies to all of the apps that by default, especially the Microsoft apps in the App Store, in the built-in ones. But what he found was even after pushing this group policy out, that the mail client would still say, you can see here, you need to switch to a Microsoft account. So the question is, why isn't this group policy effective at forcing the right behavior? For that, he turned to Process Monitor. All right, it's getting a little better. It's late in the week, isn't it? All right, so he traced the application launch, and let's go back and take a look at it. And you guys are sick of making you say, when in doubt, or do you like it? Do you like it? When in doubt? Oh, okay. Some of you. That's good. So let's go back and take a look at the optional MSA account log file right here. And so we have the mail launcher. So let's take a look at the mail launcher and what it's doing. He didn't know what actually the registry value behind that group policy setting was. He guessed it was probably MSA optional. And so he just typed in a search for MSA optional. And as luck would have it, that is the exact value behind that group policy setting. And he sees this. He sees the mail client. You can see it's the runtime broker, which is running the host for the mail client. And it's accessing HQLM software, Microsoft Windows current version policy system MSA optional. Now, the key is missing. Anybody know what's going on here? Okay, well, I'll tell you. Here's the group. He traced the group policy editor to see how it was configuring this thing. So he went back to this. This is the MMC group policy editor snap-in, saving policy objects. And here's the policy object that got set. Now, does anybody notice a difference between this, what might cause that other thing to fail? And I'm kind of giving you a clue. That's all I can zoom in, so I hope you figured it out. If you look, that's a user in the user. It's a user-based policy, and here it's a system-based policy. You want me to make you dizzy again? No, I won't do that to you. So it looks like the mail client of all the apps on the system was checking the wrong place for this. So he fixed that by pushing out his own custom registry setting to force HQLM to have that MSA optional value in it instead of using the group policy editor to do it. And then he reported the problem to Microsoft, which meant that he sent it to me. And I haven't told the mail guys about it because it's such a great example. So don't tell them about this. Okay, so we're cruising towards the end here. And the last section is blue screens. How many, and this section, a lot of you probably are like, okay, whatever, not relevant, so you're excused now. How many of you experienced blue screens? In the last year? In the last 6 months? In the last month? The last week? The last day? Last hour? Wow, there's somebody back there. Well, so those of you that have been to this talk before know that I'm a collector of blue screen paraphernalia. And I'd like to share that with you, my latest batch of blue screen stuff. And some of this you've seen before, but there's some new ones in here. This is the SeaTac baggage claim. I don't think that luggage is actually going to show up. This is airport. This is fresh. This is like from a month ago. I think that's, anybody recognize the airport? I'm sure there's somebody in here. DFW, there we go. Yeah, DFW. Here's another one. That's not actually a blue screen, but Windows Update is about to up. Yeah, hits close to home, doesn't it? This is, some of you have probably seen this before. This is a subway ticket vending machine in New York City, in the subway, in the metro there. They've upgraded these things since then, but this was about a year ago, and you can see they're still running NT4. So now they've upgraded to XP. So. And here is it blue screening. This is billboard. It's on the side of the road. DHL, I don't think that package is getting there. CompUSA's bestseller. This is just an oldie but goodie. It's Best Buy's top seller. So I don't know if these are related. Like CompUSA had blue screen on their bestseller, and now Best Buy's got a blue screen on their bestseller. And what happened to CompUSA? This is intentional. It's actually really cool now to do blue screens. This is a techno act, and he's got blue screen stuff playing behind him. So I like this guy. It's Crestron. Dave Solomon. This is a classic too. There's a few of Dave like this in public places next to blue screens. And what he just can't resist doing is going and looking at the blue screen, figuring out the most likely cause, and then turning to everybody that's within earshot and telling them why it's crashed. And this is Dunkin' Donuts. Blue screen, flight information. You can actually, jump on this one and it makes waves. This is a class. I cannot stop showing this one. You probably might have seen this one too before, but this is a gas pump, and this is the reason for it. This is not a joke. That is in the Building 26 parking lot at Microsoft. A picture from there. And then I've got to make the obligatory, I think that's the Task Manager developer's car. This is an oldie but goodie too. Somebody said, I've got a problem on the PC. This is old because people don't fax anymore, but tech support's like, hey, why don't you copy that stuff down? And of course, the tech support guy thought that'd be the end of it. And then an hour later, this shows up on the fax machine. And this is kind of cool. This is at a gas pump. Sysinternals tool, being running at a gas pump. I don't know why the license. So PS kill. So somebody must have automated this thing. So you can see PS kill asking for somebody at the pump to agree to the terms. And this is Kitty Care. I don't know what this thing is selling. Morrison's UK's favorite baby website. Kiosk machine. This is at a mall. Some of you, anybody recognize this place? What? No, this is like in UK someplace, I think. No, that's actually not. What is this down here? Okay, so I guess this is someplace in Russia. But here's a conference center at Microsoft. And upside down, which is, can't get anything right at the conference center. Now playing in Nashville, blue screens. Olympics, this is the Beijing Olympics, the most visible one ever. Here it is. There's to give you the idea. Here's on the inside of that, whatever that net, whatever they called that thing back then. Here's the London Olympics. So blue screens at the Olympics seems to be a theme. Paddington Station, telephone, airport, burger. This is air traffic control in the Ukraine. Actually, I was told it's not. This is in Kiev, and actually this was on the news because this is in their city center. But I think they also use it as their air traffic control as well. Just kidding. It's a health station, TV announcer announcing blue screen of the day. And this made me so proud. I get this email one day at work. You can see it's earlier this year. Uh-oh, it's from my daughter. And I'm like, what is this? This came up on my computer at school. Ha-ha. And so she came home and told me that she'd done it. I said, well, did you fix it? And she said no, and so I made her go and do her lessons. And then here, she's processing. And then here's, of course, the oldie but goodie as well. As you remember, the Iraq War. And then we're back to the beginning. Anyway, so a little diversion there. I've got some good ones that people have sent me. Okay, so let me tell you about how to debug blue screens, how to fix them. So when you get a blue screen, most of the time you probably just reboot and then just hope it doesn't happen again. Literally with a few minutes, you can many times get to the root cause of the blue screen and get a driver update or figure out what you need to uninstall to make sure that it doesn't happen again. Of course, a blue screen every now and then, that just might be something you're willing to live with, but again, the pain, how pain-free it is just to get a hint in most cases makes it worthwhile. A few things you need to know to be able to debug a blue screen. One, where is the crash dump file? So Windows generates a crash dump file whenever it crashes, and depending on which version of Windows you're on, older versions like Server 2003 sometimes would write to the Windows directory if you've got a full dump, or the mini dump directory if you've configured it for mini dumps, or XP if anybody's running XP, same behavior. And starting in Vista, you get kernel dumps going to, only the most recent one going to the Windows directory, and then you get mini dumps being collected in the Windows mini dump directory. The golden rule here, so you don't have to remember all the rules and combinations, is go for the one in the Windows directory. Windows memory.dump is what you just should open. Just fire up WinDebug, the same tool that we were using earlier to look at that proc dump crash, point at Windows, open memory.dump. If there's no memory.dump there, then go into Windows mini dumps, and then open the most recent one, because that's most likely the one that you're interested in. Open it up in WinDebug. What's going to happen at that point if you've configured symbols is you're going to get the same kind of prompt that we saw before. In fact, it'll do a basic analysis. You press Analyze-V, which you'll see in a second, and it'll do a more thorough heuristic analysis to tell you what it thinks the root cause is, and that is it. That's as simple as what we saw before. Let me show you a real case. This one came in about a month ago. User was complaining on a user group about their system crashing. And you can see here they say, I'm having a BSOD, attempting to switch from DPC error message. I've attached the mini dumps. Can anyone help me? Thanks in advance. And he taps the dumps. There's a pointer to the post in the user group forum if you're interested in looking at it. And somebody, helpfully, this is a good group of people, know how to do that basic crash dump analysis. Somebody pulls down the dump and takes a look at it. And let's go take a look at it. So I'll go to Cases, Labs, Case Demo, Case of, and I go to Hibernate BSOD and open it up. And this will take a second here. I'll do Analyze-V. I just hyper-clicked on that, so that'll open up in a second, and it will show me its best guess as to why this particular user's machine is crashing. Okay, this is timing out on a, again, CorpNet thing at Microsoft. It'll take a second. Come on. All right, I'm going to give up here in a second and just go back and show you the screenshot instead, if this is taking too long. All right, let's just do this. This is what you would have seen. Driver Urkel not less or equal, IRQL. This is a illegal access of memory at the wrong processor state on the machine, so the wrong Windows processor state. And very common type of driver bug, and this is the driver that caused the problem. Anybody recognize that driver? There's a tool that I wrote called Not My Fault. And that's, here, let me find Not My Fault. Let's see. Where'd it go? Not My Fault. This is not my fault. Clicking the crash button will cause the system to crash. So, somebody analyzed the dump for this person and said, okay, by the way, are you using Not My Fault by Mark Russinovich? If so, stop and remove it. So, case closed? Actually not. The user came back and said, thanks for the help. I'm not dumb. I do, on occasion, use Not My Fault to crash my system, and because I like the colors. But this is a different crash. So here's another dump. So maybe this one is not the Not My Fault crash dump that you can take a look at. So let's take a look at that one. Let's see if maybe it's only faster there this time. So demo, okay, so I'm going to be city, and okay, it's going to be a lag again. But you can see already, kind of a hint, there's third-party drivers that don't have symbols for them. You can see that's often the clue right there. And the analysis, if you take a look, attempted switch from DPC, and then the analyze-v says that it thinks this thing is responsible. This is the stack trace that leads it to this conclusion. So it's just using heuristics. It's saying, hey, look, it looks like this driver here caused this function, which is illegal, illegal at that, to call when you're in that certain processor state. And what he did was, let me see if that, yeah, there it is. So you can see this is a very old thing, 2007. He went online and searched for this thing and saw that it was a PCI SD reader from ENE Technologies. This PCI reader, Windows has built-in drivers for most PCIe devices. Those are pretty standard. So what he did was uninstall. He went to the device manager and uninstalled this thing and rebooted the machine, and now he could hibernate successfully. So just a few minutes, opening the crash dump file, looking at the driver that was causing the problem, and then figuring out what this driver was, led him to fixing the problem. Just a few minutes, as simple as that. And that was it. So that brings me to the conclusion of the talk. I've covered a bunch of tools and techniques. Now, one of the things that people have asked me over time is, why don't you just make a recipe of, like, do this, do that, and do the other thing? You can see that this is an art as much as a science. You need to know the tools. You need to know what they can do and what they can show you. You need to understand a little bit about the way the system works. But a lot of times it's just leaps of imagination and following random clues and going and trying. I mean, there's some places in here where some of these cases that people solved were like, I wonder if that could be related to the root cause. And they start probing down that path. Now, what I haven't shown you is all the cases where they said, I wonder if that's it. And they spend some time going down a dead end. But you can see just the kinds of weird cases that people are able to solve with these tools that otherwise would be like, who the hell knows how you would solve them, and they might be something you have to live with forever. So I encourage you to always try to troubleshoot a problem if you run into it. This is what I always do. If you get a case that you solve, please send me screenshots and log files so I can add them to this talks and share them with other people like I have with you today. Remember to go check out Mark's webcasts. Check out Windows Internals, check out Sysinternals, check out my new novel, Rogue Code, and I want to wish you a great wrap-up of TechEd. Hope you had a great time this year, and I hope to see you again next year.